morning everyone. Welcome to One Concept Per Day portal. And today the concept that we are going to deal here or discuss here is about the HR diagrams. So before we start with the HR diagrams, I would just like to give some theory based on this, okay, for 5 minutes, and then later on we'll proceed with the problems actually. Now towards it, the first thing is that we should know about what are different types of stars we have in order to understand or to interpret the HR diagrams. First thing is there are main sequence stars. These are the ordinary stars which are similar to our sun, which makes up nearly 90% of all the stars. Then there are red giants which are very large, cooler temperature than our sun. And the last one is white dwarfs, which is size is much smaller than sun and it is very hot. Okay, now let us look at the HR diagram. So HR diagram shows you something like this. It tells you about, it has something like on the x-axis you have spectral classes. There are several spectral classes which have been shown over here. And on the y-axis, there is not only one y-axis, there are several y-axes over here. There are two y-axes as shown over here. One is absolute brightness in this side, and you have luminosity on the other side. And then you have a temperature over here. Okay, thus you see HR diagram is something like it's a plot dealing with the spectral class, luminosity, temperature, absolute magnitude, star type. Okay, and few of them can be represented by the same type. Now, as you see at the same time, there are some super giants, and so on. This tells you about the cluster of stars which has the same type of property. Okay, now you see the stars which are ranging from here. Okay, as you see here, it starts from here and you see it goes like this in the form of an S. The form of an S like this. This is nothing but the stars are called as the main sequence stars. There's a possibility that these main sequence stars can get deviated from here. It can go to supergiants and then it can become a dwarf star also. So there are some rules for it. Okay, we will see this when we start solving problems. Okay, this is one type of HR diagram. Let me show you another variant of this HR diagram. Now this is the second variant of the HR diagram. Most stars fall onto a strip extending diagonally across the diagram from top left to bottom right. Now you see, so there is a line over here. I told you already, no? So that is the line. Let me put this one here. Okay, so this is a line over here. So this is your main sequence stars. Our sun is at this position over here. It's at this position over here. Let me take up my pen and indicate where is our sun actually here. Sun is at this point. Sun is at this point. The nearest star to the sun, after the sun dies, the next star which can come across is Alpha Centauri. And there are several stars which have been on the same line over here. Okay, and then you have most stars. This is called a main sequence. Some large stars, reddish in color, occupy top right. Okay, and these are called as red giants, which are large and cool, and above them are the red supergiants, which are very large and cool. So these are the red giants and these are the red supergiants and so on. These are much cooler. Okay, they are having a lower temperature. How do I know it's lower temperature? Look at this here. Okay, temperature usually should go from the origin to in this direction, but here you see it is reducing like this over here. Okay, and then so therefore along the x-axis temperature is reducing like this, and along the y-axis the luminosity is increasing like this. The bottom left is a region of small stars of white dwarfs which are very small and hot also. Okay, this is what is the classification of the stars and what you can understand from the HR diagram. See, apart from whatever information I have told you, you can also see stars which are having something like 0.1 times R0 here. What is R0? The radius of the sun. Okay, you see these are the stars which can lie on this line, and stars which have a radius nearly equal to 1 times R sun. So you see this is the radius of it. You have Sun, Alpha Centauri, then Procyon A, Altair, Sirius. All this belongs to the similar radius over here. And those which are having a much larger radius, 10 times R0, okay, you have these stars over here. And then 100 times R0, you have these stars over here, right? So therefore, thus you see these stars, the one which you called as white dwarfs, are having a radius much lesser than this. Okay, so thus you see, okay, we have already put across the temperature of a star, the luminosity of a star, finding out what is the radius of the star, finding out what is the spectral class. We have put across all this information into one diagram. That is what we call as the HR diagram. Okay, this diagram is an extremely important diagram. The moment you get this diagram, you can give lots of interpretations, you can do lots of calculations and so on. So understanding this diagram is extremely important to solve the problem. Okay, so with this we'll go on to the next our video, that is on the problem solving.